It's 7:30, and I see participants are, oh, it says my internet connection is unstable. I hope you can hear me. So welcome to the June meeting of the BNS. This is our last meeting before we take a break for the summer. And I might just start, first of all, does anybody have any announcements before I come with announcements? Does anybody have any announcements they would like to make? Operations or as true? Maybe it's not as easy to do that over Zoom, but let me, you can, if there's anybody, just jump in, but I'll start. So Howard told me the newsletter went to print today. So within a couple of weeks, hopefully we'll have the summer issue of our newsletter that should be coming out. The first thing I wanted to say. The second thing is that I sent around to all members a panel discussion on with black bird watchers, and this came up in light of the matter. And I know John Burka and I have seen it, and I know a couple of other people watched it because I got responses back. And I would say, even if you're not a bird watcher per se, it is really quite an eye-opening discussion that these, I believe there are 5 or 6 people are having, because it shows how stereotyped we often are. For example, as John just pointed out, if you're out bird watching and somebody, and if there's a person of color or a different group, like the thing to say is not, oh, you bird watch as well. So I would highly suggest that you do watch this, because it is something that I think is really important, especially given what's been happening the last couple of weeks. And it seems that things are going to change. And I think with our group, the Blomden Naturalist Society, we need to think about how inclusive we are. And this is something that I believe we should address. When you get the newsletter, you will see that you'll see that I write about that we have undertaken a strategic plan for the BNS. And so far we have done the SWOT analysis. We are going to be having a meeting in July. And after that meeting, we're hoping to involve the membership to get your input into how you would like to see the BNS maybe continue as it is, or how we might change. So keep that in mind. The thing is that I'd like Howard to give an exciting announcement. Howard, are you there? I see you.
The exciting announcement is a commercial in the middle of a meeting, and the commercial is this, right? Hopefully you can see the screen where we have a picture of the front cover of a new book, Wildflowers of Nova Scotia, a pocket guide to the common native flowers and shrubs. And this has been underwritten in part by the Blomden Naturalists and some very accommodating donors. The booklet went to the press last week for another proof, and I'm fully expecting that we'll be able to produce this document sometime late this month. It will be available late June, hopefully from BNS board members, me included. The price is $20. If you want to have it posted to you, it'll cost you another $4. This is what the front page looks like. Inside, we have just two mock-ups of pages, one for a couple of yellow flowers, blue bead lily and yellow trout lily, and two blue flowers, harlequin blue flag and wild tobacco. So we include wildflowers of all colors and include shrubs as well at the back. And I'm hoping that your members will enjoy this relatively entry-level pocket guide. And when I mean pocket guide, I really mean pocket guide. It will slip into your pocket. So that distinguishes it from many other guides that are available. So that's the end of the commercial. Thank you.
Okay. Well, thanks very much, Howard. And I should say that it's been Howard and have been working on this for quite some time now, very diligently. And last and early winter, they said that it would be ready this summer. And some of us thought, man, that's a lot of work to have that ready by the summer, but it appears that it will be. So congratulations to Howard and Carol for producing this, what I think is going to be a wonderful guide to take out when you are out wandering in the woods. Okay, well, it's my pleasure to introduce Mike Gill, our presenter for this evening. If you've been over to Canning within the last year or so, you will have noticed that there's a new coffee shop in Canning. And living close to Canning, I immediately thought that's a good place to go and sit and have some writing, etc. And and I forgot, Mike, sorry, I forgot your wife's name, but she runs the coffee shop, and she said, oh, you got to meet Mike. He's a biologist as well. And so a few days later, I did meet Mike, and it turned out that we had some common interests and common friends indeed. So as you know, I worked on the boreal owl for my research, and it turned out that Mike has worked on the saw-whet owl, very similar little critter. And as we talked about, you know, common interests and people we knew, etc., Mike had been I believe, the research assistant of a very, very good friend of mine when he did his PhD in Vancouver on Townsend Bowl, Xavier Lambert. That Mike had I believe he was his assistant, or I'd certainly worked with him. So Mike suggested that, or I think I said, oh, you should give a talk to the Bondrup Naturalist Society, and Mike graciously said yes. So this evening, this talk this evening is going to be Mike talking about a topic that we have indeed heard about, but only heard about it at a local scale. So, and this is citizen science. We've heard about citizen science locally, but now we are going to hear about the importance of citizen science on a global scale. So, Mike, take it away.
Great, thank you, Soren. That's wonderful. And I'm actually giving the presentation from my wife's cafe simply because my son is watching the NECEC athletics live stream banquet. So I wanted to come somewhere where I had some bandwidth. Let me know if people can hear me okay, and if you can see the screen. So I'll just start. So thanks, Soren. My name's Mike Gill. I've had the pleasure of living in the Canning Kingsport area for the last 6 years. I'm actually originally from Vancouver, but I met my wife Alice in the Yukon, where we lived for 18 years, but she's a maritimer. And so you know what it's like. You're eventually going to come and live in the Maritimes. So that's what I'm doing here. Most of my work is in different parts of the world, and I telework. Before I came to Canning, I worked for the Canadian Wildlife Service. ran a species at risk program, worked on owls, as Soren said, all sorts of different things. So I think what you'll find in this presentation is I'm a jack of all trades, master of none. So what I wanted to do was just profile, as Soren was saying, the role of citizen science and the growing importance of citizen science in global biodiversity observations. I co-chair a global network called the Group on Earth's Observations Biodiversity Observation Network. So this is an intergovernmental organization. Our secretariat's in Germany. My other co-chair is Portuguese. And this is a network that's run around the world, basically working to coordinate or better coordinate how we monitor the Earth's living system and really copy the climate community in that respect. I also do quite a bit of work with an organization called NatureServe, which you might have heard of, that operates throughout North, South, and Central America, working on science-based at-risk species issues. So what I wanted to do is just profile what we'll talk about here in terms of what the challenges that we face globally in terms of biodiversity observations and data, a little bit about the program that I co-chair and how we're addressing trying to improve the quantity and quality of data. And then I really wanted to talk a little bit about some really exciting new technologies that are coming out for streamlining how we basically keep the pulse of the planet and how we actually take all that information, integrate it using model-based techniques, machine learning, automated workflows, and so forth to really speed up or streamline conservation action. And finally, I'll do my best to sort of explain how citizen science really holds a really key stake in all of this. So talking to the Natural History Society, I'm sure this is no news to any of you. We're merely one species on this planet, but we take up about almost half of the Earth's biocapacity. So the biocapacity meaning the energy and materials that the Earth produces in any given year. And with that, of course, comes consequences. So in the latest Intergovernmental Panel Biodiversity Ecosystem Services Assessment, we're facing this century the risk of losing 1 million species over my lifetime. So I was born in 1970, which is kind of a cruel irony because that tends to be the baseline year by which we measure decline. So in my short lifetime, we've seen global forest areas reduced by over 2/3. There's only about 3% of the Earth oceans that are untouched by people. And through the Living Planet Index, which you might have heard of, that estimates that we've lost about 6 out of every 10 vertebrates on the planet in the last 50 years. So no surprise to any of you, this massive crisis underway that really threatens all aspects of the Earth's living system. And in response to that, in 1992, there was the Rio Convention, which led to the UN Convention on Climate Change, the Convention on Biological Diversity, all these what we call multilateral environmental agreements. We have a Ramsar Convention on Wetlands, Sustainable Development Goals, and all these different agreements, which are global agreements, come with targets, and those targets need to be monitored. So for instance, the Convention on Biological Diversity right now has 20 what we call Aichi biodiversity targets, which all countries that are party to that agreement have made commitments to. And yet, for many of those targets, we actually have no clue of whether the world is moving towards or away from those targets. And definitely at the national scale, we, in many cases, have no idea whether the targets we've set are being achieved. And that's simply due to how those targets were chosen, but also due to the lack of data on biodiversity. And this map is just a global map from something called the Living Planet Index, which is basically an indicator that's used to track the health of biodiversity around the world. What they do is they have about 16,000 different populations of vertebrates, so fish, bird, mammals, that are tracked over time, and they use that to look at whether, on the whole, the index is increasing, and therefore on balance, most populations are going up, or if it's decreasing. And not surprisingly, on this map, you'll see pretty strong bias spatially towards Europe and North America. These are the places where we tend to have the best data, but even so, it's not great data. And when you actually overlay that with a heat map of where per kilometer squared we have the highest species richness, you see a real paradox or a mismatch. So the areas of the highest richness undergoing the most rapid change are also the areas that we tend to understand the least. And my role as co-chairing this global network is to really try and create a more robust way that we can actually monitor all parts of the planet. The other big problem, again, probably no surprise to anyone here, is just that we tend to monitor and observe things that we can see or that we assign value to. And so on the left is a rough illustration of the balance of species on this planet. So of course the planet is dominated by invertebrates, and vertebrate species, which are birds and mammals, amphibians, reptiles, are just a tiny sliver of that. But when you actually look at the IUCN Red List assessment, which has so far assessed about 1.1% of all the world's living species, it's highly biased towards birds, mammals, and amphibians. And so we really have no clue what's going on with some of the fundamental underpinnings of our living system. And this is important because when you look at the latest climate change assessments, so this is the IPCC report in 2018, because of the outsized role that humans have on the planet, or in the age of Anthropocene, we're actually changing the climate, and that has some severe consequences to our well-being and to the well-being of all species on there. And so the drivers of biodiversity loss are no longer just an issue around overhunting in one particular area or habitat destruction, but we're seeing a lot of global forcing of the living system. And because of that, we really have to work together in a more coordinated, harmonized way to understand what's driving these changes and what do we do about them. And this graph just shows that basically the y-axis, if you look at the 1.5 there, that's looking at what the world might be like under a 1.5 Celsius warmer world, where we see some severe constraints on warm water corals, low latitude fisheries, the Arctic region, and so forth. And when you actually get up to 2 degrees Celsius, all bets are off, and we really start to see some major constraints on the Earth's living system. And so if we don't actually get a handle on climate change in particular, many of the other actions that we might take to reverse the decline are probably going to be moot. And of course, we're all on this meeting on Zoom because of the latest coronavirus, and that's a biodiversity story. So working with colleagues, what's happened in terms of this coronavirus is not a surprise. This was predicted. If you look at in the last 100 years at all the global pandemics, which are largely what we call zoonotic in nature, so they come from jumping from species to humans, the most common factor in most cases was rapid land use change. So as humans incur into previously wild habitats, we're exposing ourselves to more and more viruses. And as we chew up and increase the rate of exposure, these viruses, because most of them are RNA viruses, they actually can mutate very quickly. And with this latest virus, it's a fairly safe bet that this originates from something called a horseshoe bat, which is a fairly common cluster of bat species in Asia. This is a traded species in wet markets in China. It's the same bat species where we got the severe acute respiratory syndrome, or SARS, back in 2008, 2009. And so this increasing wildlife trade and this increasing incursion on wild habitats is actually increasing our risk to our own health. So with all these pressures underway and the fact that we need to really get into a more proactive stance around understanding and predicting emerging issues facing biodiversity, about 12 years ago, GeoBond, the Group on Earth Observations Biodiversity Observation Network, was formed. And this came about largely through the big space agencies like NASA, European Space Agency, Japan, Germany, and others, really deciding that we got to stop just throwing sensors up into space and not talking to each other. There's a ton of redundancy in terms of the systems that we're deploying in space. We're not maximizing the value. No one's sharing their data. Can we not actually squeeze more value out of these massive investments? And so out of that came something called GEO, or the Group on Earth Observations. So it was an agreement in 2005 to basically coordinate, at first, all our spaceborne observing systems, but now it's grown to coordinate observations writ large, whether they're on the ground, in the air, or in space. And so I co-chair the biodiversity arm, but there's all sorts of different arms to this. There's ones focused on climate, agriculture, disaster, so on and so forth. And so we focus on the biodiversity realm. And this is a global partnership of around 200 different organizations. So you'll see NASA and the European Space Agency. So some of the big space agencies invest quite heavily in this, but a lot of different environmental NGOs and UN Environment and others are key players in basically working together to create more of a network approach to how we actually monitor biodiversity around the globe. And I won't get too much into detail on this, but whenever you wake up in the morning and you look at the weather forecast, you benefit from something called the essential climate variables. And this is an agreement around the world on how and we're going to measure different aspects of the climate system. And every country in the world follows the same standards and uses the same instrumentation to do that. And with biodiversity, it's way more complex, and the biodiversity community is not nearly as organized as the climate community for all sorts of legitimate reasons. But what we're trying to do is create something called essential biodiversity variables. And they follow the same idea that can we boil down the fundamental elements of biodiversity change through a minimum set of measurements that are complementary to one another and independent of the method you can use. So you can basically roll up data from Brazil, from Canada, from Indonesia, from different parts of Africa, and you can actually say something about how the planet might be responding to things like changes in climate. And so that's a really fundamental focus that we're working on within our network, is to really define and deploy what we call EBVs, or essential biodiversity variables. And part of that is we build tools. So we have agreements between countries on how they're going to measure and monitor their biodiversity, what software tools they're going to use, what data protocols, what data standards. So we work with a lot of different institutions to sort of coordinate basically the how, the where, the why, and the what. And through all this, we also have what we call an operational arm. So we're working with different countries and regions around the world. So we've developed regional observing systems in Asia Pacific and in Arctic and in the tropical Andes, where we're basically putting all these standards and tools together to build what we call workflows. And this is just an example of a workflow where we design a system to answer big questions such as, are we moving towards or away target 12 of ACHI, which is to lower the rate of extinctions of species around the planet? How do we build observing systems using these essential biodiversity variables that can really pull together the best data to actually tell us whether we're moving towards or away these different targets? Who are the major institutions that will curate that data, such as the Global Biodiversity Information Facility, which is based in Copenhagen? What data analytics and standards should we use? And what are the platforms we're going to use to communicate this data? So we're trying to basically come up with this harmonized approach where Canada, the US, Mexico, all around the world are following fairly flexible but similar workflows where we're able to actually share data and stream data at different scales. And this is just a map showing some of the areas where we've been working. This map's a bit old because we're building some observing systems in sub-Saharan Africa right now and in South Africa. But we've worked a lot in the Asia Pacific, the Arctic. We're piloting a lot of our work in Colombia, and just basically trying to create a globally interoperable observation network for biodiversity. So anyways, that's the dry stuff. Now let's talk about more of the fun stuff. So I just wanted to profile some of the emerging technologies that are coming out that are really kind of supercharging how we can actually monitor biodiversity, and then use that as a segue to talk about what happens when you go out and you take a picture or you record that sighting of that bird, an eBird, or you take a picture of a plant or an insect and put it into iNaturalist. Why is that important, and what happens to that data? So this is just an image from late 1970. This is what one of the first NASA Landsat satellites would do for us. So it had about a 1 kilometer square resolution, and you could use that to look at things like global forest cover, but it was incredibly crude. And I'm just going to show you some examples of how much better the resolution of things like the Landsat series of satellites has become. So this is what it looked like in 1979. If you took a 1 kilometer square pixel of the Earth, if it had some trees on it, all you could say was it was forested. You couldn't say how much of it was forested or to what degree. And then as they introduced better and better satellites, we got better and better resolution. And this is actually an area in Washington, DC area. And as you can see, the resolution gets down where you started with that sort of 1 kilometer block of green. And now we can see fine detail patterns in forest cover in this particular part of the world. And we can use that to track changes in forest loss. So this is actually part of a global data set called the Global Forest Change or Global Forest Watch data set that's used to actually monitor forests in near real time. So we get daily updates around the world on forest cover. And some of the satellites that are being used can actually pick up small scale changes such as a lowland gorilla nest. So lowland gorillas will knock down a number of trees and create a nest. We can actually see that on satellites now. And you can use this for things like identifying illegal poaching. Brazil, up until recently, used it to actually enact a really aggressive program to prevent deforestation that worked really, really well. And so this is just a schematic to show that these are just the NASA Earth observation satellites that are in orbit right now. There's lots more from the European Space Agency, DLR, JAXA in Japan, Russia, of course. We have terabytes of data streaming overhead over this part of the world. But for the most part, we have no idea what that data actually means because it's never been calibrated or ground truthed. But in some instances, we do have a good calibration now. And so, like I said, we can actually use the Landsat series of satellites to track tree cover and forest loss and gain over time. And you might be surprised that one of the fastest deforesting nations on the planet is Canada. If you look at the boreal regions and the northern areas of Canada, we actually, sadly, and most people don't know this, they focus on places like Indonesia or Brazil, but Canada's actually has the dubious honor of being one of the fastest deforesting countries on the planet. So now I'll just talk a little bit about the opportunity with cloud computing. So we'll just use Indonesia as an example. So as I mentioned, we have all these satellites streaming overhead, collecting tons of data, so much data that we don't know what to do with it. But what we can do now is use cloud computing through things like Amazon Web Services and Google Earth Engine. This is actually using Google Earth Engine, where we can actually integrate terabytes of data very quickly across a constellation of people's laptops and desktops to actually analyze and create what we call cloud-free images. And so through the power of cloud computing, and that way that we can actually democratize supercomputing power on the cheap, we can actually create these weekly images of the Earth's forest cover. And we also now use satellites to count animals from space. So we do it for elephants and other species. We do it for penguins. So this is an image in Antarctica of a penguin colony, and we're using machine learning techniques to get better and better at actually figuring out, well, how many penguins are in that particular picture. And we also actually are using satellites now to get a way better estimate of how many penguin colonies are actually out there. Because of course, Antarctica is a pretty hard place to explore. And this actually, I think, tripled or quadrupled the estimate of emperor penguins in Antarctica. Because what we can see here, these are actually basically fecal smears from penguin colonies on the ice, and you can pick them up really well with satellites. So we can use those to actually count how many colonies there are and actually track over time whether we're seeing more colonies or less using satellites. And I'm sure you know about geolocators, which is a really cool new technology, basically the size of a watch battery. And these are really, really lightweight. And so you can put them on smaller and smaller species. And all they really do is they basically record the time of day that the sun sets and the time of day that the sun rises. And that particular moment in time is unique to every single location on this planet. The trick with geolocators, you actually have to catch the animal and download that data again. So it's a bit of a challenge with that, but it's really blown away our understanding of things like migration. So there's a species of bird called the bar-tailed godwits, which nest in coastal Alaska and winter in Australia. And we always knew that they flew a long, long way. But what we didn't know that they actually flew 11,500 kilometers nonstop. They actually don't stop to rest over that massive journey. We've also found Arctic terns that nest in Greenland and winter in the Weddell Sea in Antarctica. Over their lifetime, they fly the equivalent of going to the moon and back 3 times. So 3 return journeys from Earth to the moon. So we're really understanding just the incredible nature of migration. And a couple of years ago, a new antenna was put on the International Space Station called Icarus. And this is actually a picture of the Russian cosmonauts putting this antenna on. And this antenna is really a leap forward on how we actually track animal movements across the globe. And so this antenna can pick up signals on fairly small devices that can be put on flying foxes, like pictured here, all the way down to like thumbnail size, little tiny instruments that can be put on baby tortoises, even locusts. And what we can do is actually deploy those on animals, and that antenna on the space station can track their movements over time, as well as other factors such as environmental conditions and even physiology of some of these species. So what we're finding is new ways to actually just harvest tons and tons of data on how animals are using habitats around the world. And I'll just jump to this one. This is camera traps, which I'm sure you know about. We'll go to a website that shows this. So what this is a new global network basically to track, let's see when it comes up here, to basically pull together thousands and thousands of camera traps that are being deployed around the planet to track certain species that are well captured by this, such as snow leopards imaged there. And so all this data gets uploaded onto a website and shared across the world using global data standards to actually pull that together. And the other cool thing is bioacoustics. So I'm going to play you, and so turn your volume up for this. I'm going to play you a sonogram recording in tropical Bornean rainforests. So what this is doing is basically using artificial intelligence, or what we call machine learning, to analyze sonograms to streamline how we can actually identify different species, because all these different insects and amphibians all create a unique sound, which can be picked up now through these sensors and analyzed using artificial intelligence. And so we're starting discussions with somebody called Google X. It's sort of their engineering arm of Google, to put together bioacoustic sensors around the globe that can kind of automate and basically track species presence using sound. But then, of course, we just use the old-fashioned ways. So this is a friend of mine in Colombia pulling a leaf-nosed bat out of a mist net. So, of course, we still collect a lot of key data using, you know, the tried old true measures. And so this is some bat work that we did in central Andes of Colombia, just capturing bats using mist nets. And you can get great data from that, but it's a lot of work, and you get bit. And then, of course, finally, just kind of stepping back from all these exciting new technologies, we still rely on hundreds of years of data that was collected by different explorers, mostly from Europe, that are held as collections in natural history museum collections. So we have huge amounts of data that's stored in museums, which is now being digitized and put into computer spreadsheets. Now, let's turn over to citizen science. So where does citizen science come into all of this? So the next slide is an animation to show you, since 1900 in the United States, where most of the records for species occurrences came from. So just watch the slide, and what you'll see at the top is NMNH, which is the National Museum of Natural History, which is in Washington, D.C. So this is a US-centered database that collects data on species occurrences. But watch what happens to the citizen science bars from iNaturalist and eBird as we go through this. So as you can see, the top bar is from the National Museum of Natural History, followed by the New York Botanical Garden and the California Herbaria. But as you can see over time, and you might be wondering why eBird was around in the 1930s. Well, it wasn't, but it actually is data holdings that are found in eBird that go that far back. But as we go through time, we start to see that the citizen science platforms start to dwarf all other collections. And this is just a point I really wanted to hammer home, just how important things like eBird and the third on there is iNaturalist, which you might have heard of, are to really basically equipping humans as sensors through your smartphone, through your love of nature, to actually go out and just collect observations. It massively dwarfs what any scientist can do if we can get enough people to actually collect this data. And if you jump to this website, it'll just show you, so I mentioned earlier in the talk something called the Global Biodiversity Information Facility. So when you take an eBird, when you record an eBird sighting or a sighting on an eBird or a sighting in iNaturalist, if it reaches what we call research grade, it goes into this global database called GBIF. And here you can see just how important things like eBird and iNaturalist are to these global data collections, and they're becoming more and more important over time. And if you look here, you can see the GBIF data collections in the past 10 years that went from about 100 million to 1.4 billion. And in that time, citizen science has kept pace and actually has become a much more significant part of the data holdings. And I'm sure most of you are aware of iNaturalist. This is a really cool platform created by Scott Lowry at the Cal Academy of Sciences. And it emulates eBird, but is broader in scope. So you can take a picture of an insect or plant or a snail or whatever it is, and experts can go on that site and help you identify what it is. But it's actually now using image recognition and machine learning to actually do that in more of an automated fashion. So where we have a lot of data, you can take a picture of something around here, and 9 times out of 10, iNaturalist gets pretty close at telling you what it is through the computer algorithms that analyze that image. And these are incredibly important tools for bringing in more and more data on where species are and how are they doing. And just turning to GBIF, so when you take an observation in eBird, put it in eBird or iNaturalist, if it reaches research grade, which means it has to have at least 2 of 3 experts confirm the sighting, it then goes into this global database. And I'll talk a little bit about what happens to the data that you collect when it goes into that database. So as of about May 1st, we hit about 1.4 billion records in GBIF. And this is actually, yeah, May 1st here. And so there's a huge data holding that comes into this. Again, citizen science collections are more and more an important part of the stream of data that goes into these global systems. And it's used in all sorts of different ways. So there's thousands of peer-reviewed research papers looking at everything, how biodiversity is responding to climate change globally, how invasive species are occurring in different parts of the world by actually mining the data that's found in these databases. To even understanding things like mosquito alerts, so looking at patterns of human health risk from malaria. We can actually use the GBIF records to really start to predict where outbreaks might be occurring. And so as mentioned, if you go into iNaturalist and take a picture of insect or a bird or an amphibian or whatever, it reaches research grade if 2 out of 3 experts agree that it is what you said it is, and then it gets harvested every week and put into the global database. And with eBird, it's done more twice a year. So the next week, eBird will be uploading probably hundreds of thousands of records into GBIF as it dumps that data into the global system. So how is this data used? Well, we use it for conservation, for understanding how well our protected area systems cover the species that matter most or how representative they are. We can use this as surveillance to understand threatened species and where invasive species might be coming in. There's a lot of people that are using this massive data set to really get a better understanding of crop wild relatives for food security. So are we preserving the wild relatives of many crops that we actually rely on that might be resilient to disease and climate change? On and on it goes. And we actually also use this to really understand and predict pandemics, which I'll talk about. So a few years back, some colleagues of mine actually mined the GBIF data set and looked at mammal diversity around the world. And with our understanding of pandemic risk, so animal diseases jumping to humans, this map was made. And this is basically what we call a heat map that shows risk of outbreaks. And it's a fairly crude map. So it basically is just looking at areas in the world where we have the highest diversity of wild mammals, rapid land use change, and lots of humans. And of course, places like Nigeria and West Africa, India, and parts of China really jump off the map. And it's no surprise that we're seeing more and more zoonotic outbreaks of diseases to humans coming in these areas. And we actually use the data from GBIF. So in the bottom left panel, we can look at things like distribution of species of fruit bats that carry something called a Nipah virus. This is a Hendra virus, which is quite deadly to humans. Luckily, it's not very easily transmissible between humans. So the reservoir host are various fruit bats, which then give it to pigs. And pig farming in Southeast Asia has become more and more common over time, and then it jumps to humans. And we can actually use the data that's collected by citizen scientists and researchers around the world to really predict under changing climate where these fruit bat species might be expanding their range to, and therefore where we might see new Nipah virus outbreaks. One of the last examples I just wanted to show was basically mapping and modeling biodiversity importance. So this is a map that NatureServe, an organization I work with, released about 6 months ago. And what this is it basically created thousands and thousands of what we call species distribution models. So these are models that look at the relationship between a species and the habitats that it likes. And we can't, of course, cover every single square meter of the United States to see where these species are, but we can use remotely sensed data to understand where the habitats are, and with our understanding of the habitats they like, we can start to model out where these species are. And when you combine thousands of species distribution models together, you can actually start to look at areas that harbor the greatest number of endemic species or species of highest risk. And citizen science, again, is a key data value that goes into these models. And this map is getting a lot of attention in the United States to really ask, do we have the protected area system that we need? Are we covering the areas that are most important for at-risk biodiversity? And then finally, we use global tools. So I work a lot on data visualization, where we take global data sets and time series indicators to help countries in the globe track their targets towards these different biodiversity conventions. And so we produce in near real time updates on different metrics such as forest cover loss, biodiversity habitat values, so on and so forth, through these different sort of open online portals. And again, citizen science is a key part of this. It's driving a lot of the models that are used to actually track global biodiversity change over time. And so with that, I hope that wasn't too fast or too overwhelming. If there's time, I'm happy to answer questions, get into more details as needed, but I'll pass it back over to you, Soren.
Thank you. Unfortunately, my internet connection, I had to restart it a couple of times. It was a little slow, but are there questions out there? And I think, John, you had you texted something about, or Richard, a question.
Well, yeah, I have a question about eBird, and I've been using, I'm a keen birder, and I've been using eBird for a number of years, and I've recently discovered iNaturalist, and I've started using that. There's a big difference because I think eBird, I don't know of any way that the data is validated apart from some reviewers that look at rarities, for example, whereas iNaturalist, the data is validated a lot better, I think, because of what you mentioned, which is having to have observations confirmed by 2 out of 3 people. eBird, you can put down more or less what you like, and does that go into into these databases?
Yeah, that's a super great question. Yeah, you're right. Like the eBird and iNat, you know, they're same in theme, but how they actually operate's somewhat different. And so eBird gives, I would say, a lot more latitude or trust to the observer to upload their data into these systems. But when eBird actually exchanges data into GBIF, into the Global Biodiversity Information Facility, it uses some data cleaning algorithms to actually weed out what we would consider a spurious record. So this might be, you know, a species that's just, it's not possible, or it's highly unlikely that it's been actually observed here. They also, as I understand it, use some accreditation. So they're able to actually look at the quality of your observations, and based on that, that goes into the algorithm. So if you're sort of more of a trusted birder, based on the information that you're uploading to the system, the more likely that your records will actually make it into GBIF. So they because of the sheer, and eBird's incredible, the amount of data that goes into the eBird is just mind-blowing. They have to use some of these sort of crude tools to really sort of try and use these filtering systems to pull that in. So yeah, if you put in some crazy bird location tomorrow on eBird, it's probably not going to get into GBIF. If that answers your question, Richard.
Yeah, thank you very much.
I asked, I put down.
Another question?
Yes,
Yep.
I asked before, I put it on the chat. The
Yeah.
question about, you mentioned about the deforestation in Canada, the rate of deforestation. What is the significance of that?
Yeah, well, another great question. Thanks, John. So, I mean, of course, it's a real patchwork when we're the second largest country in the world. So there's parts of Canada that are reforesting especially around here. The deforestation tends to be concentrated in the boreal forest, simply due to oil and gas activity in particular. So the oil sands, as well as seismic lines and forestry. That's caused quite a significant increase in deforestation rates. It's significant sort of at the local level. The reason why we see woodland caribou in such dire straits is due to that sort of heavy fragmentation and just degradation of their habitat, which leads to a disruption in the predator-prey cycle, which leads to more caribou being killed and less able to actually access their forage. But it's also significant just in terms of the boreal forest writ large. You know, it's not, people talk about the boreal being the lungs of the planet. That's a bit of a stretch. Really, most of the oxygen that's produced on the planet comes from the ocean, from plankton, followed by tropical rainforest areas such as the Amazon. But the boreal does contain a huge amount of carbon. And as we actually disrupt and open up these areas that are underlined by permafrost, we actually expose them to warming, and you have thousands of years of carbon trapped in the carbon cycle in the ground that's actually exposed. So there's a lot of different concerns here in terms of that deforestation rate. I'd say for me, it's largely around the issues facing boreal species in Canada in particular, such as caribou.
Yeah. Good. Thanks, John, for that question. Anybody?
Larry Bogan here.
Yes. Hi, Larry.
Hi. I was wondering, I've started using iNaturalist and I enjoy using it, but I find, is there some way that iNaturalist can become more non-selective? Like it's so easy to go out and take pictures of a red maple or a common grass, and so the database seems to be weighted towards more common things. And I wondered if there were programs or ways to use iNaturalist that allows it to become more valuable in terms of getting a better picture of the species.
Yeah, thanks for that, Larry. That's a great question. I think there is, and there's been discussions underway about how to do that. So we've actually been talking to Google and how to actually link in INAT and other species distribution databases with Google Maps, where an observer like you who's using iNaturalist would, because your phone knows where you are, would receive alerts for species that you actually could target. So you could be in an area where we think, based on the modeling or previous observations, some rare species may have occurred. So that's, if I understand you correctly, that's one way that we might be able to sort of encourage or shift the bias away from everybody just going out and taking a picture of the easy stuff, but actually trying to give people alerts of species that may or may not occur. We have something coming up where we're going to try and test that globally, where we're going to give a challenge to our global network to use iNaturalist to actually go out over a 2-day period and actually target some rare species that we think are found in different parts of the planet using these species models. So if I understood your question correctly, I think part of the opportunity here is just to try and bring in that location data and that modeling data to encourage you to actually look for those rarer species.
Yeah, thank you. Yeah, I was wondering, some organizations such as the Blomden Natural Society might be instrumental in that, in encouraging people to go on field trips with the specific purpose of looking for species.
Yeah, absolutely. And I'll bring that back to the folks at Cal Academy that run iNaturalist. I mean, they are thinking about these things and they are getting that feedback, but I think it's good to reinforce these points. And I think you're absolutely right. The Blomden Natural History Society could really do these sort of targeted BioBlitz campaigns, if you want to call them that.
Thank you.
Mike.
Yeah.
Yeah, Tom.
Yeah, it's
The
Tom.
problem, of course, yes. Oh, hi, Tom.
Hi. Yeah, I'm going to make a perverse plug here for INAT. And as somebody who works on endangered and rare things, and I'm going to say that one of the great benefits of INAT is that it does have such a focus on common species. One of our greatest problems about monitoring biodiversity is that we tend to ignore the common species. And historically, we've had very few data on common species. And most of our efforts have been expended on those species that are rare, endangered, and that's where our resources have gone. And often the common species are the ones that are most informative about change in the environment. So I'd make a plug for doing both common and rare species.
Yeah, no, I couldn't disagree with you at all on that. That's pretty spot on. It's unfortunately not so simple. I mean, we really have to have a wall-to-wall surveillance system, and you're absolutely right. I mean, that's why things like the nocturnal owl surveys are so key at being able to just kind of give us a sense of the overall health of our system. Yeah, thanks, Tom.
The issue I think with iNaturalist is that it, like, you have to be able to take a picture of the species, and there's lots of things that's not easy to take pictures of. So it kind of yeah. So that's another issue. Like, just maybe a minor problem, but still it's monitoring species that you can get good pictures of that can be identified.
Yeah, yeah, absolutely. Yeah, no, it suffers from its own bias. You know, we're going to have to get down to some eDNA samplers that you can plug into your smartphone, where you can actually just sample a piece of soil. And it's probably not that funny, because I think we actually are moving towards that. There are some automated eDNA samplers out there, but that would maybe be the way to go if we really want to see what's out there in our environment.
Yes, exactly. Any other questions before we close this session? Here's your chance to speak up. Maybe just getting back to deforestation, like in I think it's in the last 30 years in Nova Scotia, half the province has been cut over. And deforestation, of course, is one issue, but this repeated clear cutting is another issue that impacts biodiversity. So issues to deal with.
Yeah, that's right. No, and yeah, fully agree. It's not just a matter of, is there a forest there or not, but what's actually the quality of that forest, or what's the condition of it? And it's a big challenge.
Yeah.
Yeah.
Can I say something, Soren?
Yes.
Okay, I was just, thank you so
yes,
much.
Absolutely.
Very, very, very excellent talk, Mike, and the presentation and the quality of the slides, and it was very interesting. But I was also thinking about the deforestation issue, because when when Irving or someone reforests, it's a monoculture, and so that's not what you want either, and that can be problematic for bringing back the natural habitat for animals and species.
Yeah, absolutely. Maybe I'll just mention something. This is a challenge globally. So, for instance, the Food and Agricultural Organization relies on every country to report their own forest statistics. So, for instance, Indonesia calls oil palm plantations forest. So it looks like they're actually reforesting, but they're not. But there's ways around that. So there's new instruments on the space station. There's something called JEDI, which is the Global Ecosystem Dynamics instrument. And all it is it's a laser. And it's basically just firing a laser onto the Earth's surface millions of times a day across the track of the space station. And by doing that, it actually can measure what we call vertical structure of habitats. And by doing that, you can really start to pick apart the real forest from the plantation forest, for instance, or what's the quality of the habitat. And so we're trying to actually blend all these different data sets together to really get a better understanding of like what's the really key forest that's left on this planet that actually has some value that we should be focusing on, but can we also use this as a way to be a little bit more honest about how we're managing our forests.
And also to make the governments
Yeah.
more transparent too.
Absolutely.
Good. Thanks. Yes. Thanks, Heather. Any last questions? Hearing none. We have been recording this session again, and I'm not sure, at our last board meeting, Pat was talking about setting a BNS YouTube where these recordings are going to be, so that soon, if you're interested, go back and watch. I said this was the last meeting before we take a break for July and August, and we'll be back in September. And at this point, I don't know if we will be able to get back and use a room at Acadia. I think it depends a lot on, what happens between now and then. But I will let everybody know what to expect in September. And as I mentioned at the beginning, we are in the process of doing some strategic planning for the BNS, and we will be looking for input from the members, and that will be coming later this summer. We fully intend to have something, a strategic plan ready for the November general members meeting. So try on that. And just a final plug maybe for the wildflower guide that Howard and Carol have been putting together. As soon as it is available, we will be sending out an email about its availability and how to get a copy. And if it's in fact ready later this month, then there'll be lots of time to use the guide in the summer when you go out and botanize. And I'm certainly looking forward to getting a copy and taking it with me. So finally, Mike, thanks so much for the wonderful presentation that you gave. And excellent.
Sorry,
Applause.
can I ask one thing?
Thank you. Yes.
Steve and I are both looking for, I'm helping Soren next year with looking for speakers, and we have some in mind for the fall already, but if other people have some great ideas like Mike for during the winter, we would be happy if you could suggest them to us. So to give us a little bit of a bio on the person. And so send an email either to Soren or myself, and we'd be happy to consider them for speakers for next year.
Thanks,
Yes.
Mike. Great talk.
Yes, thanks, John.
Thank you so much. That was so good.
Good. Yeah, good talk.
Oh, thanks a lot. Yeah. I should say
Thank you,
congratulations
everybody.
to Soren, too.
And we will. For what?
That was it.
Oh, yes, we're done.
Good. Thank you. Okay, I think this is it, and we'll see you. And I'm going to leave now. So.
So, Mike, what is
Have
your
a good rest.
contact information?
I'll put it in the chat box before
Okay.
it leaves, or Soren can probably share it too.
Thank you very much.
I put my email in the chat.
Perfect. Thanks.